Welcome to another RoboRAM education session. Today's topic is autonomous vehicles and the things to consider in order to minimize collisions through extensive research. Let's get started on another case study on robotics. Vehicle safety standards have been raised over the decades due to the demands of automobile users and organizations such as the Federal Motor Vehicle Safety Standards and Regulations, National Highway Traffic Safety Administration, European New Car Assessment Program, Society of Automotive Engineers, and others. Superior technology-developed vehicles, which need more resources, provide a variety of amenities to the occupants. With more drivers respecting autonomous systems, the gap between them and the autonomous systems is narrowing. Although it provides elegance and dependability, it can also work against the occupants. People desire to get to their destinations faster during computer-governing travels. Automatic systems may result in deadly outcomes in the event of an unanticipated error. The most prevalent and crucial aspect of automobiles, however, is their crashworthiness. To ensure vehicle reliability and occupant safety, the vehicle structure should be built in such a way that the collision effects and shock are progressively absorbed, rather than creating an abrupt deceleration that causes injuries and fatalities. To reduce failure risks, the entire vehicle should be evaluated, beginning with the basic structure of the vehicle from the standpoints of statics and material strength. The system's natural frequencies and dynamic loading should then be gradually added. In general, pre-captured dynamic road data aids in the development of the vehicle structure for dynamic loading. During the development period, previously defined systems such as the vehicle's concept design and shape should be protected, but the adaptation of the adjustments should only have a modest impact on the design. The causes of accidents should be explored before evaluating the impact reaction and behavior of the vehicle during a collision. A significant number of accidents are caused by the driver's carelessness, negligence, and recklessness. Preventive driving strategies are the first method of lowering the chance of a collision. Although it requires time, patience, and talent, this approach is part of the education for expert driving. Even this preventive strategy, though, might be frustrating if there isn't enough attention and reflexes. Furthermore, if all situations are examined, the environmental and road conditions, as well as the flaws of other cars, including the drivers, have an impact on the vehicles as other elements. As a result, UAV technology becomes the system's savior, either totally resolving the issues or reducing the faults to a manageable level for a more reliable drive. An experimental study is the most appropriate way to establish the causes, despite the fact that it is not the most cost-effective or time-consuming method. Crash testing is the most important among all other test techniques, such as positioning, loading, and calibrating. The sled test is a widely used experimental approach in crashworthiness research after real-time collision tests. When compared to the other approaches, the sled tests are more under control. However, most businesses and facilities are unable to afford the financial burden. Many industries use computer-aided simulations to disentangle their crashworthiness problems after obligatory impact testing, lowering crash test costs. As a result, if almost the last 3 decades are examined, computerized approaches are extremely trustworthy. Many sophisticated computer-aided analysis softwares are available on the market to tackle real-time simulations of engineering challenges. Despite the fact that some softwares for exact engineering solutions, such as structural analysis, impact analysis, and thermal analysis, remain in the market is dealing with multidisciplinary engineering solution packages that use the finite element approach, FEM. However, for the most part, FEM and its solution approach are not focused on critical challenges. As a result, the more applications in software, the lower the expertise approach. Impact simulation codes, in our opinion, show the most important aspect of vehicle crashes. The explicit dynamics approach based on the FEM, therefore, gets over the tough problems satisfactorily for the impact processes. The image at the top depicts the finite element model of a wheelchair crash simulation using a sled test, while the bottom image depicts the model's finite element simulation outcome for a certain time. LSDYNA, a product of the Livermore Software Technology Corporation, is one of the most popular and widely used software for the impacts. Some software businesses utilize this code as a fundamental explicit dynamic solver. With the use of confirmed FEM results, reliable processes for determining real vehicle crash scenarios will be created, even for UAV technology. During improvements, reverse engineering applications are generally used from start to finish to repair flaws numerous times. Let's take a look at collisions in self-driving cars from a different angle. In terms of market demand, the importance of unmanned autonomous vehicles for everyday, industrial, and military applications has recently increased dramatically. It's complicated enough not to start mass productions today, especially when the automobile industry's manufacturing capacity is taken into account. When it comes to saving a human being, however, we should reconsider everything related to military achievements in the fight against terrorism or warfare. The military sector is concentrating on aerial vehicles to inspect needed zones and reduce dangers from foes or terrorists. An unmanned aerial vehicle, UAV, as depicted in the image, is a type of aircraft that does not have a human pilot. It is also known as a drone or an unmanned aircraft system, UAS. As a result, an aircraft without a pilot signifies that a human is still alive, but in the wrong hands, this advanced technology will be extremely dangerous to innocent people. Furthermore, the more professionally UAS is required, the more skilled and talented employees are required in particular challenging and difficult responsibilities. This may result in unforeseen errors during tasks, resulting in accidents and collisions. This is the Turkish Aerospace Industries, Incorporated's medium-altitude long-endurance, MALE, UAV. The next topic is Google's self-driving automobile. UAV technology is being influenced by technical advancements in a variety of fields, including media and entertainment. Drones are now widely employed by professionals and amateurs in a variety of applications since they are easy to control, simple, and inexpensive. This option has certain potentially dangerous consequences due to the system's simplicity. Although the cost of simple applications like as drones is lower than that of complicated vehicles, the repercussions could be similar. In the vehicle sector, certain top corporations, such as Google, have been paying attention to self-driving automobiles for quite some time. After many years of research and development, the results of UAV technology on the roads are rather amazing. Regrettably, even for the most advanced technological firms, certain unfavorable situations result in the UAV's negative outcomes. On February 14, 2016, Google's self-driving automobile crashed with a public transportation bus in California, USA. Despite highly improved car technology, crashes are unavoidable in some situations. Whatever is done or intended to advance UAVs, these vehicles will occasionally run into unavoidable obstacles, resulting in mishaps that were not expected. In these conditions, vehicle safety and crashworthiness should be considered from a broad perspective. Based on current research, we have learned the necessity of addressing collision in autonomous vehicles thus far in this session. We'll learn more about these advanced vehicles in the future session, and we'd also like to go on an autonomous trip. Take care and have a nice day.